Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at reference models. We'll be discussing the benefit of using a layered model, the OSI reference model, the TCP/IP protocol model, and then finally we'll do an OSI and TCP/IP model comparison. This episode is part of my series on Introduction to Networks. I'm Kevin here at KevTechify. Let's get this adventure started. This reference models, typically it's a layered model, and there's several benefits to having this layered model. Now, when we talk about networking and the models that we use with them, there's usually two models we use. We talk about the OSI model and the TCP/IP model. And as you can see, they're designed in layers, and the benefits here are they assist in protocol design, meaning protocols work at a certain level. They don't span more than one level. They only stay at that level. And so that way they can define how each of the levels between they can define how each of those levels receive and send information to the layers above them and below them. And with that being defined, then we can see different protocols being set up there. Each of these layers then help us foster competition because different vendors can make different protocols at these different layers. For the longest time, we've had different protocols. We have TCP and UDP at the transport layer. We have IP version 4 and IP version 6 at the internet network layer. Which is better? It depends upon your network, but you're free to choose. These vendors chose that. It also prevents technology or capability changes affecting one layer or another layer. If you make a change at the transport layer, does that change anything? Take this example here. On the physical layer, you have a wired connection coming into your computer. Now, let's take and unplug that and switch to your wireless card. Do you have to use a different web browser? Because I unplugged my wireless connection, that means I have to close Firefox and go into Chrome. No, it doesn't mean that. We just changed the physical connection, the network access layer, and all the other layers stayed the same. And that's one of the big things about this, using the layered model, is we can change what's happening at one layer and it doesn't affect everything else. The OSI reference model is one of the two models we use for networking. It describes how we get media from the user being able to see it on the screen all the way down to that signal going across the medium. As we look at this, couple things to understand about the OSI model. A lot of times we number our OSI model. We start with the bottom layer being number 1, so the physical layer is number 1, data link layer is number 2, 3, 4, 5, 6, and all the way up to 7 being your application layer. So a lot of times people will say, do you have a layer 1 problem? Well, it's the physical layer. Do I need to look at my cabling to make sure that that's right? That would be an example of that. And now, each one of these layers, they serve a different part. The physical layer, layer 1, it describes the means to activate, maintain, and deactivate physical connections. So how do I make that physical connection? How do I actually send that data on that medium? How do I send that electrical signal across that wire? Layer 2, the data link layer, describes methods for exchanging data frames over a common media. Now, how do we actually go about sending that data out? You're on your network interface card. How do we get it ready to send out? That's what the data link layer does. Layer 3, what we're looking at here is our IP addresses. It provides services to exchange the individual pieces of data over the network. How do we get that data from you to grandma so she can see that picture you just emailed her? That's what we're looking at. Layer 4, the transport layer, defines services to segment, transfer, and reassemble the data for individual communications. How do we get that data across there? How do we assemble it? How do we break it into smaller pieces? That's what we're concerned with there. Then the upper layers. Layer 5, the session layer, provides services to the presentation layer, the layer above it, and also to manage data exchange. How do we control that? It's sort of, yes, you can send, no, you can't send, you have to send in this format. That's what happens at layer 5. Layer 6 provides for common representation of data transferred between applications. So how do we get that? How do we get the same data in one web browser and another web browser? And then actually layer 7 contains the protocols used for process-to-process communications. How do we get that web page displayed on our screen? We go through all of those protocols there, looking at that. The second model we look at is the TCP IP model. Notice this one only has 4 layers. OSI model had 7, TCP IP has 4 layers. Once again, normally we start talking at the bottom one, working our way up. Network interface, that refers to the controls, the hardware devices, and the media that make up the network. So we're looking at the physical components of that network. It controls that. How do we send the data on there? How do we know when we can send it? That all happens at the network layer. Then we have the internet layer. It determines the best path across the network. Do we go through different routers? Which router do we choose? And of course, that route can change all the time. We get into the transport layer. That transport layer then supports communications between the different devices across our network. How do we get that? How do we actually get that across our network? And then the last one is our application layer. It represents data to the user. That's that software that the end user is looking at again. And so basically covering the same thing. Now, when we look at this, we can see that the OSI model and the TCP IP model actually match up really well. The OSI model, it takes the top 3 layers, layers 5, 6, and 7, session, presentation, application. The TCP IP model, they combine that all together. Then layer 4, the transport layer, that matches up. Layer 3, the network and internet layer, those match up. The same protocols happen there. And then the bottom 2 layers in the OSI model, layer 1, layer 2, physical and data link. That is the network access model and the TCP model. Now, a lot of times, if you are a networking person, you're going to talk in the TCP IP model because you're not concerned what happens in the upper layers of the presentation, the application, and the session layers. You're not necessarily concerned about that. We're concerned about what happens on the bottom of the layers at that point in time. And so if you're a networking person, you're probably going to look at using the TCP IP model. OSI model, yeah, a networking person will probably use it. But if you're doing some sort of software application development, that's where you're going to be concerned with more, is using that OSI model. Networkers, they typically use both of them. It was my pleasure to provide you with this wonderful episode on reference models. If you like this episode and you got value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Network. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode on my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.